Hello. Um, this video will require you to be working with the first handout, handout 1. On top of this handout, you're going to notice an argument, and it's titled something that cannot be proved valid using the rules of chapter 6. So from the premises C or A and B, and it's not the case that B and A, we would like to be able to prove that C follows. Because after all, I'm sure you noticed this, but after all, the um, the the thing that is negated here and this second disjunct should be equivalent, A and B, B and A. However, since currently we have no way of proving one based on the other, we are not able to see with disjunctive syllogism that C follows from the negation of B and A. Now this can easily, of course, be remedied, which it is, and the rule for this is commutativity. So commutativity is the rule that P and Q and Q and P are equivalent to each other, that one can be inferred from the other. And this is shown, this is expressed with a 4-dot convention. Now, think about modus ponens, how we express that P then Q, P, these premises would entail that Q for any cases of P, any cases of Q. Now we have what we call here the 3-dot symbol, which stands for therefore. Now, P and Q entails Q and P, so we could say P and Q, therefore Q and P. However, we would like to note that, without making a big fuss about it, we would like to note that while P and Q implies Q and P, also Q and P implies P and Q. The 4-dot notation, the 4-dot symbol, as opposed to the 3-dot symbol, helps us communicate this. So when we talk about 4-dot rules, we're talking about a logical equivalence between two kinds of formulas, and we're saying that not only you can infer the right-hand side from the left-hand side, but also you can use this rule in the opposite direction if you want, when you need it. Of course, working your way up in the opposite direction with modus ponens is not possible. Okay, so using this new rule, what are we going to do now? We can continue, and we can do this interesting thing. 4-dot rules have a couple of features about them. One of them is what I told you before, that it works in the opposite direction. The other of them is that you can apply this rule to just a portion of a formula, just a portion of a compound formula. So we're going to be able to write here that it's not the case that A and B based on 2 commutativity. I would like you to notice or pay attention to what we did here. The thing that's in the place of P, the thing that's in the place of Q are B and A. And we reversed them and inferred Q and P. But we were doing it to a portion of a compound sentence. Now we cannot apply 3-dot rules to portions of compound sentences. Okay, so one big difference between 3-dot rules. 3-dot rules cannot be applied on portions of compound sentences, but 4-dot rules can. What I mean is that, for instance, if you have something like some sentence like, if A, then B or not C, you're not allowed to do disjunctive syllogism with this portion, this consequent here, right? Our rules do not allow this. However, we are allowed to do something like that, some operation to just the right hand side of a negation, just the main part of a negation. Okay, now let's finish this little, excuse me, let's finish this little argument. And notice that with disjunctive syllogism, C follows from 1, 3. So that's our first argument on this handout. Now, the next thing we want to do is to talk about the ways in which we can use commutativity and associativity to get certain results that we want. Now, here we saw an application of the commutativity rule. Let's think about the associativity rule. The associativity rule states that if we have a couple of parentheses, if we have a formula with parentheses, we can move that set of parentheses just like this. This is one of the associativity rules. The same thing, of course, can be done with disjunctions. One rule applies to both the conjunction and the disjunction. Of course, commutativity, in addition to the conjunction formula, also can be done with disjunctions. These two are called commutativity rules. Now, using these four rules, we are able to reorganize long sentences that have these connectives, disjunction or conjunction, in them. In your handout, you'll find an example. So in the handout, the example you have is like this. A or B or C or D is equivalent to B or D or C or A. Now you want to reorganize these atomic letters to get to B or D or C or A. Let's start with an application of commutativity and move the disjunct A to the right. This we get by commutativity from the first line. And now let's do another commutativity to change the places of C and D here. That's another instance of commutativity. And now let's use associativity and move this set of parentheses to one left to isolate B or D here. That's an application of associativity. And finally, let us use associativity one more time to move this set of parentheses one to the right. Okay, and so this finally allows us to get to the claim that is equivalent to the original claim, and the rule again is associativity. Now, one other feature of equivalence rules is that when we show two formulas to be equivalent, notice that we have done something that we have inferred B or D or C or A from A or B or C or D, and but we could easily have gone in the other direction. In fact, if you wanted to show equivalence, all you would have to do is write these exact same steps in the opposite direction. So if you use only equivalence rules, you end up with an argument that that would work in both inferential directions, would work inferentially just fine in both directions. So later we will see that when we want to show equivalences using if we use only equivalence rules, only four dot rules, we wouldn't have to infer both the first formula from the second and the second formula from the first. We can do it by using only inference rules if we want. At the end of this handout, you're going to see some things to watch out for. You're going to see that A than B is not equivalent to B than A. You obviously know this. That is to say, hook is not commutative. There's also no associativity for hook, so be careful about those. Also, if you have mixed cases of disjunction and conjunction, you shouldn't use associativity or commutativity. Now, the handout ends with a couple of easy questions. I want you to ponder for a moment. Is A if and only if B is if and only if commutative, that is to say, is this true? Can we generally say that P if and only if Q implies Q if and only if P? Sorry. Can we say this? And also, do we want to say that P if and only if Q would we want to say that these formulas are four dot equivalent to each other? Okay, so I would like for you to consider these and consider if they're equivalent. And if you like, on Thursday, if you don't know the answer or if you're not sure about your answer, you should ask Oğuz if these are good rules. Okay, so this is the end of this little video. Now you can move on to the second handout in the second video.
Made with Doodlecast Pro.